Okay, Bismillahirrahmanirrahim. This is the summary of 7th lab, that was environment sensors, that included airflow transducer, air pressure transducer, and humidity sensor. It will be a short summary, so it's not a substitute of the whole class, but this is only for those who just want to have a quick revision of what we have studied in the lab. So first one is airflow transducer. Airflow, as the name says, it senses the flow of air. Okay, and we know that the unit of airflow is meter cube per second square, liter per second, liter per second, or meter cube per second. Mechanism include this circuit, that is a Wheatstone bridge assembly, including two RTDs and two standard resistors. So first, as we know that RTD has a positive temperature coefficient. When the temperature increases, the resistance of the RTD increases. RTD has an integrated resistor with it, integrated heater with it. First of all, the heater is turned on so that the resistance of the RTD reaches to a maximum value. When this happens, then the pump is turned on. When you know that when the pump is turned on, air will flow through this RTD that will cool down this resistance temperature detector. When it is cooled down, the voltage across the resistor changes, and when it changes, then the voltage between this and this node also changes. So on the basis of how much change occurred between these two nodes or across RTD, you can have the idea of air flow. So the mechanism is very simple. You just need instrumentation amplifier and then another amplifier. As you know that the RTD, the change of resistance is not as much in RTD, so to get a readable value we need to amplify it to around 1000 times. So after instrumentation amplifier, you need to connect at least 200x amplifiers. So I have did it here. This is the airflow sensor, and as you see inside it, there are two RTDs, this one, and the second RTD has an integrated heater. So first you will wait for the heater to get heated to a certain level, and then you will turn on the pump, and you will monitor the change of voltage across the indicated nodes there. So first you need to set it on 0 with the help of offset, and now you will turn on the heater, turn on the pump. See, when you turn on the pump, the voltage across the indicated nodes will either increase or decrease. It's up to you to calculate whether it should increase or decrease. Well, it was a simple experiment. Second one is air flow transducer. Air pressure transducer. This one was used to monitor the airflow. This one will be used to check the air pressure. This is the assembly used. This is the box, and this is the pump outlet. These are provided as exhausts for air. This is strain gauge, and this is a vacuum. Now basically this assembly consists of this circuit. As you have already studied this assembly in Wheatstone bridge in the strain gauge experiment, where we have two active strain gauges and two dummy strain gauges. Pressure is applied on two active strain gauges, and the change of voltage is monitored between these two nodes. These two active strain gauges are present here, and we know that dummy strain gauges are not supposed to be present in the environment where the change of pressure is occurring. So for the dummy strain gauges, you have a vacuum. So these two dummy strain gauges will be present in in this vacuum chamber, and the active will be present here, so that when the pump is turned on, it will press the strain gauges, and then the change of resistance will occur in the strain gauges, and thus the change of voltage will occur here. Again, after that assembly is same. You need instrumentation amplifier and then another amplifier to get a readable value. So I'm not going to do this experiment, just showing you. This is the air pressure sensor, and these are the two nodes indicated there, and these one. You just need to connect the instrumentation amplifier between these two nodes, and remaining assembly will be almost like this. You can take help from the student manual as well. Now the third one, which is a humidity sensor. As the name says, it is used to check the humidity. Humidity is basically the amount of moisture or amount of water vapors present in the air. Moisture is used, the term moisture is used when the water contents are being observed in the solid substance. If the water contents are observed in the gases, then the term moisture is replaced by the humidity. Again, the assembly is very simple. This is the humidity sensor, including many capacitors in series. First capacitor is this, that has two plates. Second, third, fourth, fifth, sixth, seventh, eighth, all the capacitors are in series. It's not necessary for them to be in series. It's up to the manufacturer if he wants to put it in series or in parallel. Well, the medium between the capacitor in this case is air. So when the humidity of the air changes, the permittivity of the dielectric also changes, because the medium in this dielectric medium in this capacitor is air. So when the humidity of the air changes, the permittivity of the air changes, which changes the overall capacitance of this capacitor. So basically this is the variable. This is acting as a variable capacitor whose capacitivity depends upon the humidity of air. This is the circuit. It has a resistor in series. You apply an AC from an oscillator, and then you check the voltage across the resistor on different humidity values. Input is provided from an oscillator, and in this case, as you know that in the case of AC, the reactance of the capacitor is observed, which is equal to 1 by 2 FC. So when the capacitance increases, reactance decreases, and so the voltage drop across the capacitor also decreases. Similarly, when capacitance increases, the reactance will decrease. Similarly, when capacitor decreases, reactance increase, and the voltage drop across the capacitor will increase. But if you are checking the voltage drop across resistor, then it will have the opposite values. So I hope so you have gotten the idea of this sensor. In this trainer, this is the humidity sensor. So output is taken from here, and input is given here from the oscillator. In this trainer, the humidity sensor, the input terminal is not provided. It means it is already given input internally. So just output is taken, and as the output is AC, because we have given it AC from the oscillator, so it is amplified by an AC amplifier, and then it is rectified, and then amplified, and then the voltage drop across the resistor or capacitor is monitored. Now let's turn it on. So basically you need to blow air inside it to change the humidity. You can either blow it from your mouth, or you can simply just take your hands near it, because your hand also has some amount of moisture on it. You can simply touch it to check whether it is working or not. See, when you touch it, when you are touching it, you are basically changing its medium from the air to your skin. So both have different permittivity values, so the output is being affected. So just see, when you blow air from your mouth, the value also changes. So this was all about humidity sensors.